Hi everybody, welcome to the second class of the track number 7 of how to apply artificial intelligence techniques on container port operations and logistics. Now my name is Anibal Azevedo and now we're gonna start the last class of this track, okay? So remember that in the description of this video you have all the Python code that you can use it, and we are using also the previous tracks developments. Here we have this uh, the tracks codes. So I will not explain this again. Since in the previously class we explained it, we remembered all things that we need. So if you didn't see the previously class, it will appear as a car somewhere. And now we're gonna start just the redefinition of genetic algorithmic class to include Quay rules, okay, and also weights for multiple objective functions. So now what's important here is that we're gonna use let's the same the same code, almost the same code that we used on a previously track. So remember that in the track number number 4, we already defined a genetic algorithm and used and named tuple again. This is a very interesting thing since from collections from this model, use this to avoid pass a too long parameter to initialize this genetic algorithmic class. Okay, so what's important here is that this is the development that we made in track 4. We changed something because here we're gonna need not only the genetic parameters, okay, but we have to increase this by using weights. So we have to modify this genetic algorithm because now this gene pattern we will include some weights because we have more than one objective function, okay? It's also important to say that we still using this second parameter, which contains a series of parameters, like we have done in this genetic algorithm in track 4. Okay, we have the same things, but not exactly the same things because CS, this variable, will contain this thing. Let's see what we are using as parameters. So first we define the container ship dimensions to create an object of a container ship object. Also we have to define the number of unloading rules functions, the number of loading rules functions, and the number of query crane rules functions. Finally, we put all together in this list variable, and also as you can see here. So we have these numbers of rules for each action here. And this is the transportation matrix. This is the verbose mode that we're gonna use false. This is the sim pattern, which is important since we're gonna use the same parameters that we defined for the simulation parameters, okay? But now we also have another parameters like minimal distance between quay cranes and time to move to the next bay for the quay cranes. So these two parameters will be grouped by this name, kSimpara. This is another uh, tuple, okay? And these parameters to be used in the container ship simulation, and this for quake crane simulation, will be important to create the simulation object. This object is a new object simulation object that we defined just in track 6. Remember track 6? We defined another class that we already explained, and this is the KC, KSKCS simulation. Okay, it's a little bit confusing the name of this. Okay, but what's important here with this simulation has just the two things that is important. We have the Quay, the container ship storage problem, and the Quay cranes operation. So these two, this class simulate correctly, evaluate correctly by doing a correct coding of this. We already explained this in track 6. Okay, so what we have more here? So we already defined the simulation, how to evaluate. We are just using this, and this variable contains an object of this simulation that has all these parameters defined. So it seems to be okay, but we have also to define the parameters of the genetic algorithm. So this is the total number of combinations of integers for each port that's gonna be used for each port. It's the product of integers. It will be for 24 possible combinations of rules for each port. The number of ports is 4. The bounds of the for each port will be 1, and the lower bound and the upper bound will be 24 in terms of integer numbers. We have the number of iterations. We have the number of ports as the length of the list that will contain a solution. This is the size of the number of individuals that will be evaluated for each iteration. This is the crossover rate. This is the mutation rate. Okay, and this is the variable that will store the weights for each objective function. So we have two objective functions. We are trying to just to minimize the time, the total time, and we don't care about, we put weight 0 in the objective function of minimize number of movements. Okay, so what's important here, we put all these parameters inside this name, para. So this tuple will store all these parameters inside this variable named m. So we pass m, and also we pass this variable sysyn, which means it contains a lot of parameters here. Yeah, it's a very tricky way to store many information, to pass many information to this object of this class. So finally, when we already set up all things, we can evaluate, just call an evaluation of one specific solution, okay? And you can be afraid of, this is reality, it will really works. Yes, we have the proof here, and in the description of this video you can access the code. Okay, so what we have here, we just changed the you can see that selection method or initial population, they are exactly equal of the same methods that we defined in track 4. So we have mutation, crossover, selection, initial population, even the this constructor method is equal that we defined before. But one thing, it's not exactly the same. It's iteration, because iteration, we're gonna use these variables. Okay, this one is okay also. This will not change almost nothing, but one thing, it will be different and new. This objective function, we didn't use it, we didn't have this before, because this is just the values and the weights that you should use to compute the fitness of a specific, for a specific solution. So this is will give you the score. Okay, and what's important here, when we perform, let's see where okay, So see here, we use self.objective function system evaluate. This is the new thing that we use it here and also here. Okay, so the evaluation of the function will be not just system evaluate. We need another function that combines the two values that will be produced by the simulation, by using the simulation, and combine them as one objective function. So let's see what we have here. Remember that this simulation, okay, I will not say again this very awful combination of letters, very difficult to say it, but remember this: we have to return two numbers, two integer numbers, number of movements, and total time. This can be a float number, no problem about this, but we have two numbers, okay, that this simulation will return, and that is precisely the reason why we are applying not just only this let's see here, iteration, why we are using just this self-objective function. We are using this because this function is able to take any number of variables or integer numbers and combine them with the weights. Since you have provided the right number of weights, it can correctly combine them and return the properly score. So this is the main thing that we did here. Uh, Someone can say, "Oh, why not you use it inheritance to produce GA for Quay cranes or with Quay cranes?" Yeah, you can be use this and just redefine the iteration and define the new function. It can be also a very good alternative to make the code more clear and easy to read. Okay, so I believe that we covered all aspects of this code, all critical aspects, and this is if you want, you can change a lot of parameters. You have a lot of parameters to change, to test, and you can do your own research on this code as you want, as you think it's interesting to explore. So thank you for your attention again. This is not a simple framework. I had to think a lot of months, difficult months, to think about these structures in a way that it works in the more simple way, but not exactly simple, but it's easy to read. But the most important thing that is not the end, because we have the track 8, and the track 8 we're gonna see one thing interesting, that the program will automatically generate the rules. You don't need to code manually the rules that you can use in the logistics. This is a very good improvement in the program, since the program will be will be very agile, can deal with any kind of situation, or can change very quickly to any kind of situation. So thank you for your attention again, and I hope you find this video useful and interesting, and see you in the next and last track. Bye!